Okay, hello everyone. Welcome to the channel. Today I want to make something for myself. The problem with the monitor that we have at work is that it doesn't support VESA, and I don't want to go through the hassle of installing it. So I have always wanted this thing to be higher to my eye level, and yep, there are two main parts. I want it to be at my eye level, and I want it to be custom fitted to this fit so that it doesn't wobbles around and doesn't need to be that huge on the table. So a minimal area for the monitor desk. That is all about it. So I want some so I want something that can raise the monitor up for about, let's see, this high, 15, I don't think 15, like 20 centimeter from the table. Yeah. So, and I want it to have a groove that will allow the monitor to fit in there. So I just imported the monitor and with the standard card. So because the dimension of the card is known, and I double check it with my caliper, it is 85.6 by 53.98 millimeter. So yep. I think that thing is pretty standardized, to be honest. So I took the picture with the card along with the monitor frame. Using this as a reference, I imported into FreeCAD, and then I hit the calibrate button. So when I hit the button, I will click the two ends of the card. So what I know is that from this end to, I think a ruler would be, of course a ruler would be better for this application due to the roundness of the angle here. But yeah, let's go for the let's just eyeball it, right? So this one should be 53.98 millimeter, and it got calibrated. Alright, let's get to work. Now I will create a new body. Sounds about it. Let's name it. You have to name everything, right? Monitor stand shelf. Yep, I think a monitor shelf is the correct term for this. And let's create a sketch on yep, I think the XY plane is the correct one to do it on. Okay, then just press OK. Now I will use the multiple line polyline tool and just roughly trace out the path of this. Just some rough point and lines so we get some started. We will constrain these later, but right now I just want something that I can start to work with. Okay, right click to cancel the tool. Oh, sorry for the fan. I think I can turn it off now. Give me a second. Yeah, if you're wondering why my voice sounds like this, is because I'm having some kind of a cold at the moment. Okay. Alright. The question is, can I move this? I don't think I can, right? Okay, let's create something like oh, can I move the picture around? Like, yeah, let's close the sketch first, but yep, placement. I want it. I don't have the coordinate system here, do I? No. Okay, I want this thing position on the x-axis to be 2 bit to the left, like 10 millimeter. Okay, 10 millimeter. Let's go back to the sketch. Select all of it, and okay, doesn't work like that, huh? Never mind. Okay. One thing I was worried about this is the distortion, but I will double check it later. No need to worry about it. Now, the main point is that I want it to be symmetrical on both sides. So we need to set some basic constraint for this. I can turn this line to GN, right? Yep, perfect. Turn those to construction line because I may want to change it a little bit. Symmetric constraint, symmetric to the y-axis. Okay, if one point move, the other have to move. Okay, a bit more, a bit closer to what I want now. Yep, I think it is due to the way I took the picture, because you see it is not like flat. Yeah, the camera it doesn't took this thing as at a 90-degree angle, and this is the problem. So I will have to fix it later, one way or another. Okay, close this thing. Is a sketch visible? I didn't see it, but I want to move it to the right again. So -5, and check out a sketch. Okay, bit better. Yep. Yeah, I think that is the problem at the moment. So we have the basic shape, but it seems like impossible to because if the bottom fits, okay, I think I see the problem now. This thing doesn't want to play nice, huh? Alright, let's just create some kind of big well. Yeah, a big pocket for this thing to fit in. Okay, yeah, I think that's the problem with doing stuff without the caliber measurement at hand. Alright, I will try to stay on one side and see how it goes from there. For this version of the sketch, I would think I will make it very basic. No fancy geometry this time. Oh, I think they already have vertical constraint. Nice. Okay, I think this is yep, I think this is enough for now. Alright, I think I can turn off this now. Now we need to constrain the sketch, right? Yeah, let's constrain the sketch. So I will should go back. Okay, GN. Okay, turn it to normal line again, and I will probably set some dimensional. No, let's not set the dimension. Just set the dimension. Is the simplest way to do this thing. Okay, the angle, let's define the angle between the lines. Okay, it doesn't like that, huh? Okay, define the angles between the two. I don't give a damn what the number is. Okay, the whole thing seems to be constrained, but it needs to be tied to some coordinate system. Okay, that's what we got at the moment. Not too shabby. I think it could work, but it's not the best, you know. Let's just leave it at that first. You know, make it happen first and then make it better. The dimension of the bamboo 3D printer is 250, right? 255 to be correct, but it's just 250 is a nice number. Perfectly in the center. Yep, I think this. I think it could sit a little bit further to the back. No, let's just keep it at this. We'll change it later. Okay, we got the first sketch. Alright. I can extrude this thing down, but let's see. Okay, let's use the keyboard shortcut, extrude, and given the thickness, I would give it like 10 millimeter, should be suffice. Alright, I got this thing. Now I will create a base for this to slide in. So click. Oh, I don't need to do that. Let's just name it pocket for monitor stand. Yeah. Alright. Now I will create another sketch on the XY plane. Okay. And I will reference. I don't need to reference. I just create another sketch. 250 by 250. Oh no, I think creating a reference would be better in case I want to change the dimension of this thing. Rectangle. Okay, I will extrude on the other direction. For how should I do this? For a lot. So like, no, let me grab the measurement tape. So it needs to extrude for 200 millimeter, which the printer can still handle, no problem. And I will name this height of monitor. I could have just named it height, but you know, name this way is much more. I think the better angle would be this one, but I'm too lazy to rotate the whole thing, and I don't know how. Okay, let's get back. Sorry for the voice. Okay, I got this one, and I want it to have some kind of shelving capability. So it will be printed on this orientation, and the process is that in this orientation the layer lines is here, which means when the gravity is applied to this plate, the whole thing will flex instead of putting pressure on the layer lines. So layer line is, it is, yep, directly on the layer lines. Is that correct? Yep. There may be a channel splitting, but I think it is not a problem for that. I'm bad at explaining this thing. So I think I should sketch a little bit more before diving into that. Alright, now I will, this is just a sketch, right? So yep, create a datum plane, and I will create a sketch based on that plane. Alright, turn off the visibility, and I want to have a shelf on this thing. So like GX will turn on the reference, external geometry reference. External geometry reference. I need to improve my pronunciation again. Alright, we got that one, and we already took slice off 10mm, and I would like to have another 10mm below that. So this will be the cutout, just to be clear. So this is what I would want. So like 250 minus, I think I can live with 3mm wall, maybe 5mm. 3mm is a bit thin, but I am really curious of the structural integrity of how much can it handle. Yeah, so I can go with the box design and have smaller boxes in it. Okay, let's try this. Alright, this thing to this thing, I want at least 20mm to compensate for the pocket. These two lines should be symmetric to the center. Perfect, because it is a rectangular, the other constraint follows. And I want the dimension from this to this. There isn't a line yet, but wait, it should still work, right? D for dimension, okay. I want it to be 3mm. I know that 3mm is very thin. Should I go for 3 now? You know what? I think I want to risk it with 3mm. It's not like I'm gonna jump on it or anything, and it will have a lot of surrounding structure. It's not gonna be a hollow box. Alright, 3mm for that, of course on the other side as well, and another 3mm for the bottom. Okay, close the sketch, and where we I have set up the shortcuts. So this shift extrude, what the heck, shift extrude. Okay, this thing, oh my goodness, okay, this line over here is 250, so we will want to cut in and left 3mm on the panel. So I want this side to be enclosed, so it would be 250. Oh wait, can this thing do math? 250 minus 3mm. Yep, it can do math. Let's double check this thing. How long is this line to this line? 247. Perfect. yeah, if you don't want to do little math like that, just input the math directly. Alright, I got the cutout, which I don't think is the most because I want this to be the drawers pocket. Let's edit it a bit because this is the base sketch, which is okay. But I kind of want something with a bit more character, you know. I want more shelving for it. So in that case, I will turn this thing into construction line first. GN. Alright. And I would want to add a shelf. Yeah, I want to add a big shelf on the bottom. Let's say halfway up that thing. No, let's not do halfway because we need to compensate for other things as well. We can implement the constraint later. And 2 smaller shelf up here. Alright. Okay, now we're getting somewhere. The walls, the distance between this thing and this thing. What is it doing? Oh, should be 3 millimeter. Alright. Same for this thing. 3 millimeter. As well for this. So 3 millimeter divider between them for some structure. Alright, not too shabby. I want these two to be equal. Alright, they are now equal, and I want these two height to be also equal to each other. Now we'll close the sketch, and okay, this is more more to what I'm envision. So pocket inside and allow me to slide it in. Okay, looking a little bit better now. Now how do I make it better? This thing is decent, but 250 is quite a lot of space. How should I resolve this thing? Okay, so like I should measure my mouse, the size of the headphone I'm using, the size of the mouse I'm using, and other miscellaneous stuff that I put at the table, like eye drops and stuff like that. Alright, we're getting somewhere, and I think this thing is a perfectly printable product right now. It will print like this. Anything put in from this direction on this surface will just flex the entire structure without stressing any single layer. Okay, looking pretty well. I would like to go and measure this thing out. This is a generic solution, to be honest, a very generic solution. And yep, very basic generic solution. Put the monitor on. I have the space in between, stuff like this. Nothing to think about. In fact, it's up, yeah. Because of the pocket, I wouldn't worry about slightly misaligning stuff and making it tip over. Okay, looks fine to me. I really wish I have you guys, my audience over here, so I can ask your opinion on how I can improve. Of course, I will add some chamfer on this edge, because it will print on this, right? So add some basic chamfer for these lower corners as well, to make it easier to print and give it a little bit more structure integrity. Simple design, it will work, but I want to put a little bit more thought into it. But yep, that's the beauty of designing on a computer, right? You get to do it again. So I think I will wrap this video up early. Yep, that is the version 1 of the monitor shelf. Of course, I will iterate on it very soon, and stay tuned for the videos. Remember, the journey of 1,000 miles begin with a single step, so stay tuned for the next step.